Cosmos by Carl Sagan. Have you ever really looked up at the night sky? I mean, truly looked? Get yourself away from those glowing city lights. Find a clear night without the moon, and suddenly you'll see something magical. A river of pale light spilling across the darkness above. The ancient Greeks imagined it was milk from a goddess's breast. The Kung people of the Kalahari Desert call it the backbone of night. For most of human history, that's all the stars were to us. Gorgeous decorations, fuel for myths and bedtime stories. They were pretty lights in the sky, nothing more. We lived our lives down here on this little world, completely convinced we were the center of everything, the stars of the cosmic show. But here's the thing. One of the greatest adventures our species has ever embarked on has been the slow, sometimes painful journey of discovering that we were absolutely, completely wrong. The book we're diving into today, Cosmos by the brilliant astronomer Carl Sagan, tells that adventure story. Published back in 1980 alongside his groundbreaking television series, it sold over 5 million copies and found its way into homes on every continent. But this isn't just another science book gathering dust on a shelf. It's a story about us, about how we, a species literally made from the stuff of stars, woke up one day on this tiny world and started asking the big questions. Where did we come from? Where are we going? Carl Sagan wasn't your typical scientist locked away in a lab. He was a poet of the universe. He had this incredible gift for taking the most mind-bending, complex ideas and making them feel personal, even intimate. He believed science wasn't meant to be hoarded by academics in their ivory towers. It belongs to all of us. It's our birthright. Today, I'm going to take you through the heart of his masterpiece. But fair warning, this isn't just a dry summary. Think of it as an invitation to join a journey that spans from the shores of what Sagan called the cosmic ocean, all the way to the edge of forever. By the time we're done here, you won't just have a few more facts rattling around in your head. You'll feel, somewhere deep in your bones, that you're part of something vast and beautiful. You'll understand that the same forces shaping distant galaxies are also shaping you, and that the story of the universe is, in a very real way, your story too. So ready? Let's set sail on the cosmic ocean. Our story begins in an unexpected place, not in the cold darkness of space, but on a quiet beach in Japan, where fishermen tell the strangest tale. For centuries, they've been pulling up crabs with markings on their shells that look disturbingly like the face of an angry samurai warrior. Local legend says these crabs are the ghosts of the Heineke clan, warriors who died in a massive naval battle right here in 1185. Out of respect for these fallen fighters, the fishermen toss these particular crabs back into the water. They refuse to eat them, which raises a fascinating question. How on earth did the face of a warrior end up carved onto a crab's back? The answer, as Sagan explains, isn't magic or ghosts. It's evolution, working its slow magic. See, the patterns on crab shells are inherited, passed down through generations. Ages ago, purely by chance, a crab might have been born with markings that looked vaguely, just slightly, like a human face. A fisherman hauling up his net might have been startled, felt a chill of superstition, and thrown it back. Now think about what happens over time. If you're a normal-looking crab, you end up in someone's cooking pot. Your genes stop there. But if you're lucky enough to have a shell that looks a bit like a face, you get a free pass back to the ocean. You survive to make more baby crabs. Fast forward hundreds of years, and the crabs whose shells looked most like samurai faces were the ones surviving and reproducing. The fishermen, completely unaware, were acting as agents of selection, essentially breeding samurai crabs into existence. This process is called artificial selection. It's how we transformed wild wolves into poodles and Great Danes. It's how we turn scraggly wild grasses into plump corn. Humans pick which traits get passed on. But here's where it gets really interesting. If humans can create such dramatic changes in just a few thousand years, what can nature accomplish with billions of years at its disposal? This is the key to understanding life itself. The process is called natural selection. Nature does the selecting. The environment is the fisherman. And the result? Every single living thing you've ever encountered. Hummingbirds, giant redwoods, bacteria in the soil, your neighbor's annoying cat, and yes, you. Evolution isn't just a theory you can take or leave. It's a fact, as solid as gravity. And it's the first crucial piece of understanding our place in the cosmos. It tells us that all life on Earth is connected through an unbroken chain stretching back billions of years. We're all distant cousins. You and the oak tree down the street share a common ancestor somewhere way back. We are all, as Sagan so beautifully puts it, one voice in the cosmic symphony. The music of life on Earth is intricate and stunning. But is it the only song playing? Are there other voices, other melodies, echoing from worlds scattered across the light years? To answer that, we need to ask something more fundamental. What is life actually made of? Sagan has this wonderful line, "If you want to make an apple pie from scratch, you must first invent the universe." It sounds playful, but it's making a profound point. Every ingredient in that pie, the carbon in the apple, the oxygen in the water, the nitrogen in the wheat, is built from atoms. And where did those atoms come from? Except for the very simplest ones, every atom that makes up you, me, and everything around us was forged inside a star. Think of a star as a cosmic kitchen. It takes hydrogen, the simplest element created shortly after the Big Bang, and under crushing pressure and intense heat, it cooks it into heavier elements. Hydrogen fuses into helium. Helium becomes carbon and oxygen, and everything else on the periodic table. When a massive star reaches the end of its life, it doesn't just fade away quietly. It goes out with one of the most violent events in the universe. A supernova explosion so bright it can briefly outshine an entire galaxy. In that final spectacular death, it scatters all the elements it created across space. The iron in your blood, the calcium in your bones, the carbon forming the backbone of every cell in your body. All of it was created in a star that lived and died billions of years ago. You are, quite literally, made of star stuff. This is the second crucial piece of the puzzle. The ingredients for life aren't rare or special. They're scattered throughout the universe. The raw materials are everywhere. This idea that the universe might be teeming with life, that we're not the center of everything, isn't new. It's actually an ancient insight, born during what Sagan calls humanity's first great awakening. It happened about 500 years ago in a region called Ionia, on the coast of what's now Greece. For thousands of years before that, people explained the world through gods and their moods. An earthquake meant Poseidon was angry. A thunderstorm meant Zeus was throwing a tantrum. Nature was mysterious, and the gods were unpredictable. But in Ionia, something revolutionary happened. A new idea took root, one of the most important ideas in human history. The universe isn't controlled by capricious gods. It operates according to natural laws. And here's the incredible part. We can figure out those laws. This was the birth of science. A man named Thales was among the first to suggest the world could be understood without invoking supernatural beings. He thought everything was made of water, which wasn't quite right, but his approach, seeking natural rather than supernatural explanations, was a giant leap forward. Another Ionian, Anaximander, proposed that life emerged from mud and that humans evolved from simpler animals. He suggested the Earth was a body floating in space, held in place not by pillars or giants, but by being equidistant from everything around it. Then there was Democritus, who gave us the concept of the atom. He imagined cutting an apple in half, then in half again, and continuing until you reached a tiny particle that couldn't be cut anymore. He called it atomos, meaning uncuttable. He declared that everything, including us, was just atoms moving through empty space. Nothing exists but atoms and the void. These Ionian thinkers were laying the foundation for our modern world. And nowhere was this spirit of curiosity more alive than in the greatest center of learning the ancient world ever knew, the Library of Alexandria. For centuries, the library was civilization's brain and heart, the world's first real research institute. Scholars studied everything. They gathered books from across the known world. Ships docking in Alexandria were reportedly searched not for contraband, but for books. Any scrolls found were copied, and the originals kept for the library's collection. It was here that a man named Eratosthenes pulled off one of the most elegant experiments in history. He ran the library and happened to read in an old papyrus that in a town to the south called Syene, on the longest day of the year at noon, vertical sticks cast no shadow. The sun was directly overhead. Simple observation, right? Most people would have shrugged and moved on. But Eratosthenes was a scientist. He wondered, would a stick in Alexandria cast a shadow at that exact same moment? He decided to find out. And, sure enough, it did. Now, how could this be? How could the sun be directly overhead in one place, while casting a clear shadow just a few hundred miles north? Eratosthenes realized there was only one answer. The Earth's surface must be curved. And not just curved, he could calculate exactly how curved. Since the sun's rays arrive essentially parallel, the difference in shadow angles told him everything he needed to know. He measured the shadow in Alexandria at about 7 degrees. 7 degrees is roughly 1/50th of a complete circle. He knew the distance between Alexandria and Syene was about 800 kilometers. So he reasoned that the full circumference of Earth must be 50 times that distance. His calculation, 40,000 kilometers. He was almost spot-on correct. With nothing more than sticks, observations, some walking, and a curious mind, a man in ancient Alexandria measured the size of our entire planet. This was the power of the Ionian awakening. Humans were beginning to understand the cosmos through reason and observation. But the boldest of these ancient scientists was Aristarchus, from the island of Samos. He took the next daring step, arguing that Earth wasn't the center of the universe at all. He proposed that Earth was just one of several planets, and that all the planets revolved around the sun. He even suggested the stars were other suns, just unimaginably far away. He was absolutely right, but the world wasn't ready. It seemed obvious that Earth sat still while the heavens wheeled above us. Aristarchus's radical insights were forgotten, buried under centuries of conventional thinking. And then tragedy struck. The classical civilization that created the Library of Alexandria began to crumble. Slavery, mysticism, and growing hostility toward learning eroded that beautiful Ionian spirit. The library, housing centuries of accumulated knowledge, was destroyed. We're not entirely sure of all the details, but we know the result. Only a tiny fraction of those books survived. The work of Aristarchus, containing the blueprint of our solar system, was lost. As Sagan puts it, it was as if our entire civilization underwent brain surgery, and most of our memories were wiped clean. The world fell into a deep sleep for 1,000 years. Science went silent. The reawakening began in the Renaissance. A Polish cleric named Nicholas Copernicus independently rediscovered what Aristarchus had figured out centuries earlier. He proposed that the Sun, not Earth, was at the center of our system. The idea was still dangerous. The Church condemned it, but the seed had been planted again. This brings us to one of Sagan's heroes, a brilliant, stubborn, deeply religious man named Johannes Kepler. Kepler lived in the early 1600s, a time of turmoil and superstition. Trained as a theologian, he became captivated by the mysteries of the heavens. He believed God was a master geometer and that the universe must be built on principles of mathematical beauty and harmony. Kepler inherited the best astronomical observations of his time, painstakingly compiled by the great Danish astronomer Tycho Brahe. For years, Kepler tried to fit Tycho's data from Mars into a circular orbit, the perfect shape everyone since the ancient Greeks had assumed was correct for celestial bodies. But it wouldn't fit. There was a tiny discrepancy, just 8 minutes of arc, a sliver of sky so small you couldn't see it with the naked eye. But Kepler's integrity as a scientist wouldn't let him ignore it. He later wrote that those 8 minutes pointed the road to a complete reformation in astronomy. He abandoned circles, he experimented with ovals. Finally, almost desperately, he tried the mathematical formula for an ellipse. It fit perfectly. Kepler had discovered the first law of planetary motion. Planets move in ellipses, not circles. He went on to discover 2 more laws, describing how planets speed up as they approach the Sun, and revealing the beautiful mathematical relationship between a planet's distance from the Sun and the time it takes to orbit. For the first time, the true mechanics of the solar system were revealed. The harmony of the worlds, as Kepler called it, wasn't the mystical perfection of circles, but the subtle, elegant harmony of physical laws. He believed he'd read the mind of God, but the language wasn't what he'd expected. Kepler's work paved the way for Isaac Newton, who made a breathtaking leap of insight. The force pulling an apple to the ground is the same force holding the moon in orbit and keeping planets on their elliptical paths. He called it gravity. Newton showed that the laws of physics weren't just for Earth, they were universal. The same rules apply everywhere, from your backyard to the farthest reaches of space. This was the final step in the journey the Ionians began. Earth wasn't some special separate place distinct from the divine heavens. It was part of the cosmos, subject to the same laws as everything else. This new understanding, this cosmic perspective, enabled us to do something our ancestors could only dream about: leave our world. In the 20th century, we finally built ships capable of sailing the cosmic ocean. And our first great voyages of discovery to the outer solar system were made by 2 remarkable robot explorers, the Voyager spacecraft. Sagan describes the Voyager missions with the wonder of a child, combined with the precision of a scientist. These were our modern caravels, venturing into the unknown. Their journey was a direct descendant of the great sailing ship voyages of the 1600s, especially in Holland, when exploration and science went hand in hand. In that era, a Dutch astronomer named Christian Huygens used the newly invented telescope to discover Saturn's rings and its giant moon, Titan. He was among the first to seriously speculate about life on other worlds. 3 centuries later, Voyager was on its way to see those worlds up close. The journey was epic. The spacecraft flew past Jupiter, a world so massive that 1,000 Earths could fit inside it. It sent back stunning images of the Great Red Spot, a hurricane larger than our entire planet that's been raging for centuries. But the real surprises came from Jupiter's moons. These weren't just dead rocks orbiting a gas giant. They were worlds unto themselves, each with its own fascinating story. There was Callisto, its ancient surface scarred with craters like our moon, a testament to the violent early days of the solar system. There was Ganymede, the largest moon in the entire solar system, with mysterious grooves and valleys crisscrossing its icy surface. There was Europa, smooth as a billiard ball, covered in what we now believe is a vast ocean of liquid water hidden beneath a thick shell of ice. A network of cracks, like a shattered eggshell, hinted at a dynamic world beneath the frozen surface. Could there be life swimming in that dark, hidden ocean? We still don't know, but the possibility is tantalizing. And then there was Io. Before Voyager, we knew it had a strange, reddish color. But what Voyager discovered was beyond anyone's wildest imagination. Io was covered in active volcanoes, not volcanoes spewing molten rock like on Earth, but volcanoes erupting with molten sulfur, shooting plumes of gas hundreds of kilometers high into space. It was a world perpetually turning itself inside out, the most volcanically active body in the solar system. The Voyager spacecraft, their primary missions to Jupiter and Saturn complete, are now sailing outward, beyond the solar system, into the vast dark between the stars. They're the first ambassadors from Earth to the cosmos. Attached to each is a golden record, a message in a bottle cast into the cosmic ocean. It contains 115 images of our world, greetings in 60 human languages, the sounds of Earth, wind, rain, a baby crying, a chimpanzee calling, and 90 minutes of music, ranging from Bach and Beethoven to Chuck Berry. It's a snapshot of who we are, a testament to our existence, now hurtling through the void. It'll last for 1 billion years. The journey of the Voyagers symbolizes our own journey as a species. We began as wanderers, and wanderers we remain. We've lingered long enough on the shores of the cosmic ocean. We're ready now to set sail for the stars. But this brings us to the final and most profound part of Sagan's message. Our journey into the cosmos is inseparable from our journey of understanding ourselves. From a cosmic perspective, our planet is a tiny, fragile stage in an enormous arena. From space, you can't see national boundaries or divisions based on race or religion. You see only one Earth, a pale blue dot, the only home we've ever known. And on this small stage, we've developed a terrifying capacity for self-destruction. The same technology letting us explore other planets has given us the power to end all life on this one. The rocket boosters that launch our spacecraft could just as easily deliver nuclear warheads. Sagan asks, what might be the most important question of our time? Who speaks for Earth? When faced with our shared dangers and our shared destiny, our tribal loyalties and nationalistic pride seem petty and suicidal. The cosmic perspective teaches us something crucial about ourselves. Our survival depends on our ability to see ourselves as one species, the inhabitants of one small, precious world. The story of the cosmos is the story of a universe that has, in at least one tiny corner, become self-aware. We are the means by which the cosmos knows itself. Our minds, our curiosity, our relentless drive to understand. These aren't just human traits, they're cosmic traits. The atoms within us have been on a journey spanning 15 billion years. They were forged in the hearts of stars, scattered across the galaxy, and eventually came together to form Earth, life, and finally, us. We are, in the deepest sense, children of the cosmos. Our obligation to survive and to care for one another is owed not just to ourselves, but to the universe that gave birth to us. The exploration of the cosmos isn't a luxury or an expensive hobby. It's a necessity. It's a voyage of self-discovery, and it's a responsibility we can't ignore. Reading Cosmos isn't like slogging through a textbook. It's like sitting down with a brilliant, kind, incredibly wise teacher who genuinely wants you to share in his sense of wonder. The feeling that sticks with you long after the last page is one of profound connection. Sagan's greatest gift is weaving together science, history, philosophy, and a deep sense of humanity into one coherent story. He shows us that science isn't some cold, sterile process of collecting data. It's a passionate, courageous, deeply human adventure. The stories of Eratosthenes, Kepler, and the other pioneers aren't just history lessons. They're parables about the power of human curiosity and the courage required to challenge what everyone knows to be true. For me, the central message of Cosmos is the transformative power of the cosmic perspective. In our daily lives, we get so consumed by our small worries, our ambitions, our tribal allegiances. The universe seems remote and irrelevant to our day-to-day existence. But Sagan reminds us we're not separate from it, we're in it, and it's in us. When you look up at the stars, you're looking back in time. Understanding how a star lives and dies helps you understand where the atoms in your body came from. Seeing our planet as that pale blue dot helps you grasp how precious and fragile our home truly is. This perspective isn't meant to make us feel insignificant or depressed. Quite the opposite. It's deeply empowering. It tells us that in a universe containing 100 billion galaxies, our world and every being on it is rare and precious. In 100 billion galaxies, you will not find another. That single line is one of the most powerful arguments for compassion and tolerance I've ever encountered. If there's one practical takeaway from this book, it's this: practice curiosity. The Ionian awakening began because a few people weren't satisfied with easy, conventional answers. They dared to ask why. They dared to observe the world for themselves. That spirit drives all progress, not just in science, but in every area of our lives. So here are a few simple ways to bring the spirit of Cosmos into your own life. First, next time you have a clear night, go outside and really look up. Don't just glance. Take your time. Find a constellation. Think about the fact that the light from those stars has been traveling for years, decades, or even centuries to reach your eyes at this exact moment. Think about the fact that you're made of the same stuff as those stars. Let yourself feel that sense of awe. Second, practice perspective. When you're facing a problem or conflict that feels overwhelming, try zooming out. Look at it from 10,000 feet up, then from orbit, then from the moon, from the edge of the solar system. Most of our earthly squabbles shrink to insignificance when viewed against the backdrop of the cosmos. And finally, never stop asking questions, never stop learning. Our journey of discovery is just beginning. We're the first generation that can truly explore the solar system up close. We're the first capable of listening for messages from distant civilizations. What an incredible time to be alive. I've done my best to share the essence of Cosmos with you today, but let me be honest. A summary is like looking at a postcard of the Grand Canyon. It gives you a taste, but it's nothing like standing on the rim yourself, feeling the wind, seeing that vast chasm stretch before you. The real magic of this book is in the journey it takes you on, in Sagan's beautiful prose, and in those quiet moments of reflection it inspires. This summary is just a map. If anything we've talked about has sparked your curiosity, I really encourage you to take the voyage yourself. Reading Cosmos isn't just about learning facts. It's an experience that can fundamentally change how you see the universe and your place within it. And if you found this journey valuable, please take a moment to subscribe and share it with someone who might enjoy setting sail on the cosmic ocean. It helps us continue exploring the ideas in these incredible books. Let's keep growing and wondering together.